So we've been doing problems about angular momentum. In this problem, we have angular momentum of a bat and a ball. And the problem says you have a batting machine that's swinging a bat, which we're going to treat like a rod, and it's hitting a baseball. We want to know the velocity, the tangential velocity of the baseball. And this is new because we're talking about angular velocity of something that's moving linearly. So what's given in the problem is the mass of the bat, the length of the bat, which we're going to call r, the angular velocity of the bat, the mass of the ball, and the distance of the ball away from the point when it hits. We want to find the tangential velocity of the ball. So we treat this as a conservation of angular momentum because the question says, what does the velocity of the ball have to be for the net angular momentum of the system to be 0? So we set the angular momentum of the bat equal to the angular momentum of the ball. We know that we're treating the ball like a point mass, so its moment of inertia is mr squared. And we know that the moment of inertia of a rod swinging about the end is 1/2 ml squared. So then we just plug in what we know. I like to solve for our unknown variable first. And then you plug in all of these variables in here, and you get that the angular momentum, the angular velocity of the ball is going to be 20.9 radians per second. But the question doesn't ask for angular velocity, it asks for linear velocity. So then we solve for the linear velocity of the ball, given your definition of angular velocity, and we get that the velocity of the ball is 23 meters per second. So when you're looking at situations, you always have angular velocity, you always have angular momentum, even if the object is moving linearly. And that's going to help you when you work your problems this week. Good luck.